Hello students, today we'll complete the last part, that is part 5 of your chapter 2 acid, base and salt, class 10 science chemistry. Let's start. Here we are going to learn about some important chemical compound and basically that are being derived from the salts. So here let's see what is the nature of salt. We know that salt is the compound that is formed by the combination of acid and base. When you mix acid and base, it forms salt and water. Now, depending on the category of acid and base you have chosen, you get different kind of salt. For example, if you choose a combination of strong acid and strong base, then the resultant salt will be neutral. If you choose weak acid and weak base, that is same category, then also there is a resultant of the neutral salt. Next, if you choose a strong acid and weak base combination, then the resultant salt will be acidic in nature. See, the acid is strong and hence the salt is acidic. Same way, if you choose a weak acid and a strong base, then the resultant will be your basic salt. That means whichever is the strong, that nature prominent or become prominent in the salt. So if your base is strong, it will be basic salt. If your acid is strong, then it will be acidic salt, right? Some example of neutral salts are sodium chloride, calcium sulfate, then ammonium acetate. Some acidic salt are ammonium chloride, ammonium nitrate. Some basic salt are sodium acetate, calcium carbonate, etc. Okay, so these are the nature of the salt, and we get the nature of the salt from the nature of the acid and base combined to form the salt. Here from we'll talk about some of the chemical compound. So basic chemical compound that we are very used to or that is very much familiar with us is our common salt. Now how we get the common salt? The common salt or the table salt is formed by the blend of hydrochloric acid and sodium hydroxide solution is called sodium chloride. So what is the chemical name of the common salt? It is nothing but the sodium chloride that we use in the food. The salt we commonly consume. Sodium chloride is the salt that we commonly consume and it is neutral in nature. This is also used as a raw material for preparing different other materials or other compound. For example, sodium hydroxide, chlorine, baking soda, washing soda, baking powder, bleaching powder, and much more. So sodium chloride can also be used as a raw material for preparing a variety of important chemical compound. Next, we'll see how to use sodium chloride to derive such compound. So we'll start with the preparation of sodium hydroxide and chlorine from sodium chloride. In this process, what we do, we take a saturated solution of sodium chloride. Okay, here you can see we have taken saturated sodium solution of sodium chloride, that is called brine solution. The term is brine solution. Now, when we take this brine solution and we connect it with two electrode, that means electrolysis process we will do, connecting with the battery using two electrode. At that time, the sodium chloride dissociate and it produce sodium plus ion, chlorine gas and hydrogen gas. Now the chlorine gas will get deposited at anode and chlorine gas at cathode, and sodium hydroxide form near cathode. Here from we can collect it. If we put a outlet here, we can collect the sodium hydroxide. This process, that means the process in which we prepare chlorine, then sodium hydroxide, that is alkali. It is, if you remember what is alkali, alkali is the base that is soluble in water. So we get alkali sodium hydroxide by electrolysis of a brine solution. Brine solution is saturated solution of sodium chloride in water. The name of the process is chloralkali. Chlor is the term came from chlorine, and alkali, you already know, it is a water soluble base, that is sodium hydroxide. So in this process, what we got from sodium chloride, we got chlorine gas, hydrogen gas and sodium hydroxide. Now chlorine gas is given off at the anode, we already learned it. Hydrogen gas will be accumulated at cathode, sodium hydroxide solution formed near the cathode. The reaction took place here was sodium chloride plus water, because we have taken brine solution, aqueous solution of brine, that is sodium chloride, saturated sodium chloride solution, will pass electricity. Here you have to give I. It produces sodium hydroxide, chlorine and hydrogen gas. This is an important reaction. You have to remember where chlorine gas is accumulated and where hydrogen gas and sodium hydroxide accumulated. Next we'll see how to get bleaching powder. So if you remember, we got sodium chloride and sodium hydroxide from sodium chloride. Okay, by passing electricity we got this too. Now the chlorine that is formed in the previous reaction, that means in the chloralkali process, if we pass this chlorine gas that is produced in on passing electricity through a brine solution, that is in chloralkali process, through dry slacked lime. Now slacked lime formula is calcium hydroxide, CaOH whole 2. It produces bleaching powder. So we'll collect the chlorine gas from chloralkali process and will pass the chlorine gas through calcium hydroxide. They will react and they form calcium oxychloride. What is the common name of calcium oxychloride? It is nothing but your bleaching powder, CaOCl2. So here from one important question comes that what is the chemical formula of bleaching powder? Okay, you have to remember chemical name is calcium oxychloride and formula is CaOCl2. Now let's see what is the use of bleaching powder. Bleaching powder is used in several purposes like bleaching. Bleaching means decolorization. Bleach means to remove the color. Okay, so it is used as a bleaching agent for bleaching cotton, linen, and textile industry, in washing cloths. Then to bleach wood pulp in paper industry, we get the white paper. The paper is being made white. That means all the stains are being removed by using the bleaching powder. Then oxidizing agent, it is also used as a good oxidizing agent. You know what is oxidizing agent? That gives a lot of oxygen to the reactant. Then it is also used in disinfecting drinking water, that means to kill the germs. Next important compound is baking soda. Now the same chlorine that is produced in chloralkali process, if we pass it through ammonia, it produces baking soda. The chemical formula of baking soda is NaHCO3. The chemical name is sodium hydrogen carbonate or sodium bicarbonate. It is a mild non-corrosive basic salt. Okay, it is a basic salt but not corrosive, not harmful. The preparation reaction is chlorine we got from sodium chloride, so we can also start from sodium chloride or directly you can also write here Cl2. So NaCl plus H2O, when you pass current through it, it produces chlorine. With it, if you pass some carbon dioxide gas and ammonia, that is NH3, it forms ammonium chloride and sodium hydrogen carbonate. So this sodium hydrogen carbonate is your baking soda. If you heat this sodium hydrogen carbonate or baking soda, you obtain sodium carbonate, that is Na2CO3 plus water plus carbon dioxide. So on heating sodium hydrogen carbonate, what you got? You got sodium carbonate, water and carbon dioxide. Water and carbon dioxide gas will goes off and the remaining part is sodium carbonate solid. The use of baking soda are as follows. It is used in food preparation. Okay, to bake something, to make something crispy, we use the baking soda. Now this baking soda, if it undergo a reaction with edible acid, mild edible acid such as tartaric acid, it forms baking powder. Baking powder makes your food very much crispy and baking soda make your food fluffy. This baking powder on heating undergoes following reaction. So NaCO3 plus Adipial acid means H plus, acid is H plus, it forms carbon dioxide, water, sodium salt of acid. Now see, carbon dioxide is a gas, okay. This gas, if you're mixing this soda along with some acid in the food, then what happens? It produces carbon dioxide. This carbon dioxide actually make your food fluffy. The carbon dioxide produced make your bread, cake, rice, thereby making them soft and spongy. You get the soft food. Next compound is your washing soda. Now, this is another chemical derivative of sodium chloride. Why sodium chloride? Because we are following a chain, okay. From sodium chloride we got sodium hydroxide and chlorine, and this chlorine is being used to manufacture bleaching powder, then to your baking soda, then to your baking powder, and next is your washing soda. So we have already seen how to get the baking soda. Now if we take the baking soda and heat it, this is a common reaction already we just studied, that is sodium carbonate, water and carbon dioxide produce. Now this sodium carbonate, if you recrystallize, that means with water you will heat it and let it crystallize rapidly, then what happens, some water molecule trapped in the formula, and this result in the formation of this washing soda. So see here, this is another chemical derivative of sodium chloride. The heating of baking soda produces from sodium carbonate. So sodium hydrogen carbonate you have taken, you have heated it, you got sodium carbonate, water and carbon dioxide. This on recrystallization forming washing soda. The formula is Na2CO3 plus 10 water. 10 water get added up, so you got Na2CO3 10 water. Okay, so what is the formula of washing soda? Na2CO3 dot 10 H2O, sodium carbonate with 10 water molecule in the crystal. This is also a basic salt. It is used in the glass, soap and paper manufacturer industry. It is also used as used to produce some sodium compound like borax. Borax is a reagent to detect the metal in the lab. It is also used as a cleaning agent in the domestic purpose, and it play important role to remove the permanent hardness of water. Now, what is the permanent hardness of water? Some water, if you collect from pond or a dead well, you'll see that when you add detergent or soap, the soap or detergent don't function properly, okay. You will not get any foam or lather, okay. Your whole detergent will get on waste, your clothes will not get clean, because the water is not of good quality. That kind of water is called hard water, and the hardness of water happen due to some calcium and magnesium salt present in the dissolved form in them, okay. So to improve the quality of water, what we do, we use that sodium carbonate 10 water, that means the washing soda. Now this is a topic, water of crystallization. We have to understand what is that water of crystallization is. Now in the previous formula of washing soda, what we have seen that 10 water molecule is present in the formula, okay. So the number of water present in the formula unit of any compound is called water of crystallization. The definition goes as, the fixed number of water molecule present in one formula unit of a salt is called water of crystallization, okay. In the formula, whatever number of water is present, that is called the water of crystallization. So here from you just tell me, this is the formula of washing soda, okay. Na2CO3 dot 10 H2O. So here how many water you can see? You can see here 10 water. So what will be the water of crystallization of washing soda? The answer will be 10. 10 water molecule is present in the formula, so water of crystallization is 10. Is it clear? Okay. Now, one more example is given. There are 5 molecules of water in one formula unit of copper sulfate, and hence the chemical formula of hydrated copper sulfate is CuSO4.5H2O. So what will be the number of crystallization here? Water of crystallization present in hydrated copper sulfate is 5. 5 water is there in the formula, so water of crystallization is 5. You have seen this copper sulfate in the lab as well, okay. So 5 water is present in this hydrated copper sulfate. Now this 5 water molecule give the color to the copper sulfate, okay. the copper sulfate look this beautiful blue in color, it appear blue in color just because of the presence of this 5 water molecule in it. Now anyhow, if you remove this 5 water molecule by heating the crystal, then what happen? The color will also fades away. If you heat this copper sulfate and if water molecule vaporizes out from the crystal, then what you get? You don't get any more blue color, rather it become white color powder. Again, if you keep some water, you hydrate the salt, 5 water molecule will be trapped in the crystal and again it will appear blue in color. Next is your gypsum. Is an example of again a hydrated salt. In gypsum we have 2 molecules of water as a water of crystallization. So the chemical formula of hydrated gypsum is calcium sulfate CaSO4.2H2O. Water of crystallization is 2 water is there. This gypsum, if you heat, then what happen? It lose 1.5 water molecule. So from 2 water molecule, if 1.5 water molecule goes off, then what is the remaining part? The remaining part is CaSO4.half H2O, and the name of this compound is plaster of Paris. This is commonly known as plaster of Paris, and chemical name is calcium sulfate hemihydrate. Half is hemi, okay, hemihydrate. So in plaster of Paris, water of crystallization is half, and in gypsum, water of crystallization is 2. The chemical, see, the salt is same. In gypsum also you are getting calcium sulfate. In plaster of Paris also you are getting calcium sulfate. But the difference is what? The difference is water of crystallization. Okay. In gypsum it is 2 and in plaster of Paris it is half. Hemihydrate in plaster of Paris. Here are some use of plaster of Paris. Plaster of Paris is used to support your bone if it get fractured. When you get a fracture in your hand, finger or bone, you'll see the doctor wrap a white color paste, it becomes solid. Okay, so it gives us support, it give a good support to your bone so that it don't get displaced. Now when you mix with water, it again changes to gypsum and form a hard solid mass. The reaction is as follows. So plaster of Paris formula was calcium sulfate half water. With it, if you add 1.5 water or 3/2 water, it form calcium sulfate 2 water, that is gypsum. So there is a question they asked that how many water you have to add to convert plaster of Paris to gypsum. So your answer will be 1.5 water. So that much for today. Thank you.